Okay, we're diving into 3.2, the second part of it, where so far we've been dealing with a couple of equations, right? We've done that velocity, forgot the stupid board's not working. Velocity is what? How do I find velocity? Sorry? Change of distance, yep, displacement, divided by time. Because again, remember this is meters per second, and this is meters, and this is second, right? And we learned acceleration, right? Acceleration is what? Good. Change in velocity over time, right? So you could even call that Vf minus Vi all over t. Cool so far? And we also took that same equation, this one right here, that A equals Vf minus Vi over t, and then we switched it around to find for Vf, right? That Vf was equal to what? Vi plus A times t. And again, all we're doing is just moving our terms around, right? No difference in our equation. But they want to show you here on page 71 that what do you do when your something is already moving when it starts to accelerate? Because in this, we were pretty much assuming that Vi was 0, right? Most of the time. You could add a little bit to it. But what if it's already been moving? It's already covered some ground already with that initial velocity, right? And now we're adding acceleration on top of that. If you look at that graph that's there on the top of page 71, can you see that if you just did the acceleration, all you would get is that green triangle, right? The graph looks something like this. And they're saying, this is the accelerated part, right? But we can't forget about this displacement that happens because it already had initial velocity. Are you with me? Because remember, displacement is the area under a velocity time graph, right? This is my velocity time graph. So the area underneath here, that's calculating how much distance we've traveled. That's displacement. Yep. What is the slope of a velocity time graph? What does that tell us? Not speed. Acceleration. Acceleration. Because again, this y-axis is velocity, is speed. Cool. All right, so therefore, in order to be able to calculate that area, we have to use a slightly different equation that's there on page 71. Yeah, if you want to see the whole chapter in a nutshell, if you flip back to page 81, you can see them all right there. Because yes, there are two new ones I'm going to show you today. Yep, so there really is 4 total. So here we go. The new equation looks like this. XF, and remember, what does X mean? That's displacement. The V would be velocity, right? So XF, so final displacement is equal to XI. In other words, the initial displacement you've gone if you give someone a head start, plus VIT, and they say TF. Again, rarely do we ever start at any time other than 0 for time, but we'll put it there just to make sure. And are you comfortable? This is the same equation you already know, right? That distance is rate times time. We cool? So that's basically calculating the blue part, right? And then the last half of the equation is plus 1/2 AT squared. And again, that is TF. And that's calculating for us the area of this guy right here. So if I'm trying to find a final velocity, a final displacement, I need to know a number of pieces, right? The initial displacement, which again is usually 0. The initial velocity. Now, if that's 0 as well, like say you started at a stoplight and then you're accelerating, well, then that term is going to be 0 as well. All you'll have to worry about is the 1/2 at squared. But if you have any initial velocity or any initial displacement, you're going to use those two pieces. Yes, ma'am? That's really actually what they're doing here. Yeah. Right. Because this is velocity, this is meters per second, and this is time. So that's why it actually comes out to the acceleration times time squared. It's basically, you have to have the time squared to get rid of both the times, so you're left with just meters. This is the way they show you, and you're going to get the same answer, because you may not actually have the velocity final. Because again, notice, you don't need velocity final here. All you need is just acceleration. So it all depends on what you need, or what you have, I should say. Displacement. X is displacement. Yep. Are you with me? Now, Joyce is bringing up a good point here. What if I want to know about velocity? Notice there's no real velocity here other than just that initial velocity, right? But what if I don't want to know displacement? What if I want to know velocity? Well, then I can solve this out. And again, they show you on page 71 how to make that change, to solve it for velocity. And you end up with this equation, where you end up with Vf squared equals Vi squared plus 2a xf. Sorry, I made a mistake there. Gotta erase that piece. Xf minus xi. And again, this is an f. What's missing from this equation? I heard it. T. So there's no time there, right? We have velocity, we have acceleration, we have displacement, but there's no time. So this one is an equation you can use if you don't have time. Not if you're running short like you're late, but like if you don't know what time is. Does that make sense? And again, on page 71, they show you how they calculated and changed this equation to get to Vf squared. Yes, ma'am? Sure. Yeah, the other terms would just be 0 then. Yeah. You are usually assuming that there's going to be something here, yes. Otherwise, if it's not, you just pop in zeros and you go from there. Yeah. Yeah, you're correct. Okay, let's take a look at these practice problems. We've got a couple of good ones here. That is their example problem number 4. Take a look there. An automobile starts at rest and accelerates at 3.5 meters per second squared after a traffic light turns green. How far will it have gone when it is traveling at 25 meters per second? I'm on page 72, example problem number 4. Okay, so what do we know? Give me the information that this problem tells us. What do they tell us? Okay, acceleration is what? Good. What else does it tell us? I'm sorry, I can't hear you. Cool. Vf is what? 25 meters per second. Good. So far our units match up. What else? Ooh, what's Vi? How do you know that? Good. It starts at rest, it says, right? Good. Okay. What else can we assume? It doesn't tell you straight out. Sure. So that's xi is 0 as well. Because why not just start at 0? It doesn't give us any direction about that.
Wait, why is xi at 0?
Because we're just going to assume that it's starting at the beginning of something. It just makes our calculations easier. If they give you some sort of head start or beginning placement, then go for that. But otherwise, the displacement, the distance, like the position. Yeah. Yep, the initial spot they're starting from, like the starting line.
And that usually on the x-axis.
Right, so xi. Yep. Because again, and x is not necessarily x-axis. We're thinking about the plane, the x-plane. We'll do stuff that's falling. That's actually the next section we're doing, and that'll be y. We'll use y for displacement instead of x. We're just thinking, again, don't think of a graph. Think of just the actual planes. We're dealing with horizontal motion right now, so we're going to use x. When we deal with vertical, again, that's coming, the next section is on dropping things, like what we did in our challenge. That's going to be y. Your y will be displacement. Okay, what are we trying to find, my friends? Our final displacement. So are you with me that I would expect on all of your homework assignments that you would do this before you actually jump into your calculations? Again, some of you can do it in your head. I got that. But boy, I would encourage you to write it like this, because then it becomes obvious. So what equation am I going to use? I'm trying to find xf. I've got a, I've got vf, I got vi, I got xi. Which one shall we use that has all those terms? What am I missing here? Time, right? That should be a big jump out to you. Hey, there's no time here. So any equation with time we can't use. Do we have an equation that does not have time? We do, right? That's that VF squared one, right? So are you comfortable we're going to have to solve that? We're going to have to break it down. That VF squared is VI squared plus what? 2a xf minus xi. Okay. Can you solve that for xf? Can you get xf by itself? And I would say if you're uncomfortable doing that, you should come see me. We should spend some time with that. They show you it there, that we can solve that thing for xf equals xi plus excuse me, vf squared minus vi squared all over 2a. I moved this over here. I'll show you I moved this over here, so it becomes vf squared minus vi squared. I'm going to get xf. I'm trying to solve this for xf, right? Because that's what our problem is looking for. So I moved this guy over, so I got vf squared minus vi squared. I divided by 2a to get these guys by themselves, right? So now I have this divided by 2a. And I have xf minus xi, so I have to add xi to get xf by itself. Okay? And again, I promise you, this is just algebra. It looks crazy because there's all these xf's, and it's just simple algebra. What you do on one side, you do to the other to get it by itself. And now I just plug in my numbers, right, guys? So let's do it. So xf is equal to, what was my xi? 0. Cool. What was my vf? 25, and I'm going to square that, right? Minus, what was my vi? 0 squared. Divided by 2 times, what was my acceleration? I'm sorry? 3.5. Now, remember, signs make a difference. Was anything here moving in a negative direction? Or was everything going in a positive direction? It's all positive. But I want to make sure you knew if there was a negative, you would put that negative in there. Okay? If it was traveling in the x direction, or in the positive direction, and then was slowing down, that means its acceleration would be negative, right? If it was traveling in the negative direction and it's slowing down, its acceleration would be positive, right? So I want to make sure you got that. We solve it out, and we get 89. And it will be only two significant figures, because again, that's what we started with as our smallest amount. Any questions there? Mm-hmm. Any questions there?
Can you go over one more time how you got that second equation?
This equation?
Yeah.
This was what we started with, right? We picked this equation because there was no time, right? So therefore, the first thing I did was get rid of this VI by subtracting VI squared. So I end up with VF squared minus VI squared. The 2a is multiplying this term, so I divide it. 2a, again, to get it up by itself. The xi is subtracting xf, so I add xi. Again, I'm trying to get xf by itself. So those are my three steps. Yes, ma'am? Nope, that's fine. Yep. If they had given it, I don't think they even told us what direction is positive. If they would have said that east was positive, for example, sure. 89 meters east would be great. But since they didn't, we'll just make sure we have our positive and negative correct. Are you with me, my friends? You'll forgive me, I don't remember the assignment. So I got to pull it up here real quick. You are 23 to 25, 30, and 31. Okay, and again, this is 3.2, and that will be due on Wednesday. Let me pop this back up here for you so you can see. I put a bunch of things up on Schoology for you yesterday. I frankly gave you all of the assignments for the entire week here. I'm not going to be here Thursday and Friday because I'm at a teacher convention up in Baltimore. We'll go through these problems here tomorrow. We'll talk about 3.3. I'll assign the problems. Thursday, you'll look at those problems. Friday, there's a study guide, as well as Thursday, you'll work on that. And then the plan is for Tuesday, summative assessment. Again, Monday, we have no school. I think that you all should be fine. You've done well so far. If you have questions, I'm just begging you, ask. Okay, I'll be accessible via email or via text message. I can always record a little something and send it to my sub. I want to make sure you feel supported. Okay? But I need you to actually reach out and not reach out at, Monday at 11 p.m. before the test Tuesday. Tuesday is the plan. Again, all that information is right up on Schoology here. You can even, if you're anxious to get everything done, boom, you can run all through this today and then sit and pick your nose during class. I'm okay with that. Just use a Kleenex. Okay? Good. The bell is going to ring momentarily, so I will let you roll. Adios.